Welcome to Zuluba Consultants. In this video, I want to answer this question under the topic More Concept. The question reads, aluminium burns in bromine producing aluminium bromide in the lab. If 6.0 grams of aluminium reacts with excess bromine and 50.3 grams of aluminium bromide is produced, calculate A, the theoretical yield, B, the percentage yield. So for us to calculate the theoretical yield, we first have to come up with the balanced chemical equation of this reaction. Now when you look at the reactants, we have aluminium and bromine. The product is aluminium bromide. So we need to know how to write aluminium bromide. So for aluminium bromide, it involves aluminium and bromine. So we need to remember the valence of aluminium is 3, the valence of bromide is 1. So when these close multiply there, they exchange the valences, will have AlBr3. So this is aluminium bromide. Now that we have the formula for aluminium bromide, we can come up with the chemical equation. So aluminium is reacting with bromine to produce what we have just formed here, aluminium bromide. After you look at this, you will notice that this is not a balanced chemical equation. We need to balance it. So how do we balance it? If we say we introduce a 2 here, and then a 3 here, and a 2 here, this equation is balanced. If you have challenges in knowing how we have quickly managed to balance this chemical equation, you do well to watch one of our videos that we have produced on how we balance chemical equations. That will help you gain the skill needed for you to balance chemical equations. After managing to balance the chemical equation, which we have here, we need to find the number of moles of aluminium that is available. In this question, we do not need to find which one is the limiting reagent. Aluminium is the limiting reagent in this question. This is because bromine is in excess. So aluminium was consumed or will be consumed first in this reaction. So once again, there is no need of identifying which one is the limiting reagent, and it's to this reason we have not been given the mass of bromine. So let's see the number of moles of aluminium available. So for aluminium, the number of moles, we know that number of moles is equal to the mass divided by the relative atomic mass. So number of moles is equal to the mass that we have is 6.0 grams divided by the relative atomic mass of aluminium is 27.0 grams per mole. So the number of moles will be equal to 6 divided by 27. It gives us 0.222 moles of aluminium. So these are the number of moles of aluminium that are available as this reaction is taking place. After knowing this number of moles of aluminium, we can use the mole ratio from the equation to know how many moles of aluminium bromide can be produced. So the mole ratio that we'll use, the mole ratio, is when 2 moles of aluminium reacts, we can see 2 moles of aluminum bromide is produced. So 2 moles of aluminum bromide is produced. Now, what of if 0.222 moles of aluminum is available? How much of aluminum bromide will be produced? So if we have 0.222 moles of aluminum, how much will be produced this side, which is basically X? Now you can notice that this is basically a 2 to 2 mole ratio. So we can simply say X will be again 0.222 moles of aluminum bromide. So this is the number of moles of aluminum bromide that can be produced. At this point, we have managed to come up with the balanced chemical equation. We have also managed to come up with the number of moles of aluminum bromide that can be produced. So we can convert this number of moles of aluminum bromide into the theoretical yield, which is basically the mass of aluminum bromide that can be produced if all of the reactant, in this case all of the aluminum, has reacted. So let's see what we will do there to calculate the mass, which is basically the theoretical yield of aluminum bromide. So we know that the mass, which is M, is equal to the number of moles of aluminum bromide multiplying it with the mixture of aluminum bromide. So we need to know the mixture of aluminum bromide. So we have aluminum bromide there. The bromine has the relative atomic mass of 80 multiplied by 3. It gives us 240. Then for aluminum, it has 27 multiplied by 1, it gives us 27. The total will be 267 grams per mole. So this is the mixture of aluminum bromide. So we can now plug this into our equation that we have here. The mass is equal to, the number of moles is 0.222 moles multiplied by the mixture of 267 grams per mole. The mass, which is the theoretical yield, will be equal to 0.222 multiplied by 267. It is giving us 59.274 grams. So this becomes the theoretical yield that can be produced if all of the reactant of aluminum is used up. We can also round it off as 59.3 grams of aluminum is likely to be produced if all the reactant is used up. We have managed to calculate the theoretical yield. The second question is asking us to calculate the percentage yield. We use this formula to calculate the percentage yield, whereas the percentage yield is equal to the actual yield divided by the theoretical yield multiplied by 100%. So we have the actual yield, which is the mass that was actually produced when this reaction was happening, and what was produced in the lab. So what was produced in the lab is, we are saying the percentage yield will be equal to, what was produced in the lab is 50.3 grams. Then what can be produced by theory is 59.3 grams. We multiply this by 100%. So we are saying 50.3 divided by 59.3. Then this answer, we are multiplying it with 100. It is giving us the percentage yield, which is equal to 84.8% of this reaction. So this becomes the percentage yield, or the percentage of success that this reaction will have. Hopefully this video has been very helpful, and if you have any query, anything you would like to find out regarding this video, you can simply drop the comment or like this video. Thank you so much for watching it. Do not forget to subscribe to our YouTube channel and also following us on our Facebook page, that is Zulua Consultants. Until next time, it is bye-bye.